Hello, can you hear me?
Hi,
Oh, hello, there you are.
yeah,
Hey, how are you?
I'm fine, thank you.
Okay. All right. So I got a bit of a preamble before we begin. The first is this is not currently live stream. I'm still testing out the technicalities of things, just making sure things are running smoothly. But this is being recorded though, and if the recording turns out okay, I hope to put it on YouTube. Um, the second thing is that I tend to limit sessions to once per week for each person, just to make sure that everyone has a chance to book office hours. The third is that I'm on the Zoom free tier. So the session is gonna terminate in 40 minutes, and I may have to send you a new link. I'll let you know when that's about to happen.
Okay,
I think that's the final thing. Okay, and yeah, so like, oh yeah, this is not like a university course. There's no exams, there's no tests, there's no homework unless you want homework. I can give you homework, but otherwise there's no homework. The pace is entirely up to you. For example, in the beginning, you may want weekly sessions just for starting out. And at some point, you may feel like you're confident in your own abilities and you want to reduce the frequency of the sessions. Again, it's completely up to you. All right. And
understood.
yeah, before we start to get into programming, I just want to learn more about you. Like, what are your goals and what do you hope to get out of these sessions?
I just found out that you have started to teach programming, and I was really fascinated. I was really attracted to it, and that's why I want to get into it. I was looking for an opportunity, and this is when I saw your link.
Okay, excellent. Yeah. All right. So we're just gonna get started. So I'm gonna send you a link to a code editor on a web browser, and I'd like you to open it and share your screen with me. Oh, by the way, before you share your screen, just to make sure to close anything that might be sensitive.
Yeah. Okay, so the link is already. Uh,
All right. And could you share your screen with me?
yeah.
Okay, very good. Yeah. Okay. All right. To begin with, I would like you to think of two numbers. Could you write down two numbers on the left window?
Okay. Any two numbers?
Any two numbers, anything you can think of.
5. And should I use a space or
Yeah, any two
comma or
numbers.
something?
Yeah.
Okay.
Okay,
5 and
now I would
7.
like you to add these two numbers.
Uh, okay, 12.
Oh yeah, no, but I want you, okay. Okay, I would like to use the computer to add these numbers for you. How will we do that?
5 plus 7
Five plus seven.
is.
Okay, sounds good. All right, so at the top right of your screen, there's a blue run button. I'd like you to click that.
Yeah.
Ah, what's happening here?
The operator must have white space separating it from its operands.
Okay. So how do we fix this? Very good.
Like this. Yeah,
Nice. 5 plus 7 is 12. Congratulations, you've just written your first program. And you're thinking, wait, this is like using a calculator, which is unsurprising because a calculator is a computer, right? Okay.
yeah.
Let's add a third number.
Okay, so 9 it is.
Okay, let's run it. Let's see.
And should I run it?
Yeah. Aha.
21.
21. Okay. It's 9 plus 10. Very good. Very good. Um, let's change one of the plus signs to a minus.
Yeah, this. Only the plus signs.
Oh, either works. Yeah, you can do that as well.
Okay.
Okay, let's run it. Let's see what happens. Oh, wait, but could you keep
Minus
one of the
7.
plus signs? So 1 plus 1 minus. Okay, let's run it. Let's see.
Okay. The plus and operations are the same grouping level.
Hmm.
So it wants me to. Okay. Add parentheses to group the operations.
Okay, this is actually correct, but you should use the rounded bracket, the smoothest bracket. Yeah, yeah, that one.
Yeah. The operator, yeah. Yeah,
Very
3.
good. 3. Yes, that's right. Okay, so are you familiar with BEDMAS or PEMDAS?
Yeah,
Yeah, so in mathematics, there's a convention to the order of operations, right?
yeah.
Well, in this programming language, there is no convention. You have to specify the order of operations. It must be clear.
Oh,
Yeah.
now I
So
get it.
what this also means is that even though it's just one line, the computer is taking multiple steps. First, it's adding 5 plus 7, gets 12,
Mm-hmm.
and then it subtracts that by 9, right? Order of
Okay.
operations. Okay, so far so good. It's like we're using a calculator with more parentheses. Okay, can we try multiplying that with a number? Oh, in programming, multiplication is the symbol shift 8 or asterisk.
Okay.
Yeah.
You shift. Mhm. Okay, 5.
Okay, sounds good.
Okay, the minus and multiply operations at the same grouping level at parentheses. Again, one more parenthesis, but this time I'll use that one, right? The other one.
Okay. Oh, no, you still got to use the rounded parentheses. Yeah.
We need to add the before the highlighted text is the missing. Is that so?
Is that the right position for the parentheses?
No. We need to add remove some text to fix the program. So carefully before the highlighted text. Okay. Highlighted. Ah, splitting it from its fronts.
Is that the right position of the parentheses? What are we multiplying by? What's being
Five,
multiplied here? 5, right?
5.
So should the multiplication be before the 5 or before the parentheses?
Okay, now I get it. And the
I,
operator must avoid space separating from its operands.
yeah, but the multiplication
I'm
symbol,
doing
should
some
it
kind
be
of
to the left
tiny
or
run.
right side of the brackets? Sorry, should the multiplication symbol be on the left or right side of the parentheses?
Ah, am I right now?
Yes, but I think that's one extra parentheses. Actually, if you run it, I think I'll tell you. Yeah, I think that's extra. You can delete that.
Okay.
Okay. All right. Okay. If you run it now, I think it should be good.
Yeah, it
Very
works.
good. Wonderful. Wonderful. So yeah, notice the multiplication. It cannot
Yeah,
be before a right, it cannot be before closing parentheses, right? It must be between two things. Yeah.
yeah, now I know what I was doing wrong.
Ah, okay. Beautiful. Beautiful. Okay. So that's pretty interesting. So basically right now we are exploring the laws of arithmetic, but with a programming language and on a computer. Let's try something a little bit funny. I would like you to delete everything. And now I would like you to write two numbers separated by a comma. Surround everything by parentheses. And before the first parentheses, I would like you to write NUM. Oh, but lowercase n. Dash MIN. Okay, before we run it, what do you think will happen?
I think it will subtract these two numbers.
Okay, let's see. Let's run it.
It finds the minimum of these two numbers. Okay.
Exactly. Okay. Okay, let's test our hypothesis. Can we change 3 to be a bigger number?
Nine,
All right, let's run it. Let's see.
five.
5.
Yeah, it does. It
Beautiful.
finds the minimum of these two numbers.
Exactly. Excellent. Okay, so I have a theoretical question for you. How many math operations can there exist?
Mm, four.
4? Well, that's a fifth one in front of you, right? Num min. That's a math operation
Yeah, yeah.
because it's operating on numbers.
It's
So,
operating in those. Yes,
so 5. There are 5 math operations. But are there only 5 math operations? Are there more?
there can be so many more. It can also be used to find something bigger. So the bigger of the two numbers.
Exactly, the maximum. There can be an infinite number of math operations, right?
Mm-hmm.
Hmm. But there are only limited number of symbols on our keyboard. Plus, minus, times. We're gonna run out, right? So
Mm-hmm.
we need to use words. We need to use words for our math operations. In this case, num min, right?
Mm-hmm.
Yeah. Okay, let's try something. Can we add this whole thing to another number?
Uh, do I need to put an operand plus addition sign to some value?
Yeah, let's try it.
Five.
Let's run it.
Yeah,
Oh,
it works.
okay. What's happening here?
So it finds the minimum of these two numbers, and then it adds with the value that I provided, 5, and that equals 10.
Great. So it's like just now, right? The same way we can make subtraction and addition, we can do this nummin with addition, right?
Yeah.
Okay. All right, so far so good. All right, let's do something a little bit different. Right, we have just explored the laws of arithmetic here, and we're going to move forward in time a little bit. We're going to explore an idea that is algebra, which is a very, very old idea from a Persian mathematician. Let's delete everything, and let's write x equals 1. Hello?
Yeah.
All right, could you write x equals 1? Oh, equal sign, and then new line, and just write x. Okay, if we run it, what's going to happen?
1.
1. Okay, let's run it.
Yeah, it does.
Okay, expect 1. Could we change x into x plus 1? Oh, no, no, not there. Line 3. Oh, okay, yeah, no, that's cool too. And then new line x. All right, let's run it. Let's see what happens.
But I think there's an x is 1 and x is equal to x plus 1. Okay, the
Ah,
declaration is complex.
okay, so different programming languages will have different answers here. In this programming language, it's an error, which you have guessed. So the reason why this is the case is because, like, as a mathematician, when we write, oh, let x be 1, and then you write, let x be something else, the mathematician will look at you and say, okay, what did you write it, right? Why, if you wrote x already, why are we writing x again, right? We can only, so the term here is declare. We declared x to be 1, and that's it. It's now 1. If you try to change it, it's like, no, you cannot do that.
No.
Okay, can we change line 3, the green x into y?
Yeah.
And let's
Yeah.
change line 4 into y. Okay, let's see what happens. Oh,
2.
2. Very good. Which is, why is it giving us 2? Oops.
Well, because it is adding x plus 1 and x which is already declared to be 1, so 1 plus 1 is 2.
Very good. Okay, can we change line 2, x equals 1 to x equals 2? Let's run it. Let's see what happens.
Should be 3, right?
3, right?
3 it is.
All right, because we see x is 2, so, and 2 plus 1 is 3, y is 3, we see y, we see 3. So this is variable substitution. Whenever we see x, we see 2. Whenever we see y, we see 3. Yeah,
Yeah.
great. But let's try something. Can you move line 4? Can you move that y above x equals 2?
I can have to.
All right. What do you think is going to happen if you run it?
Why is not declared yet?
Ah, okay, let's run it. Let's see.
The name Y is unbound. It is
Yeah,
used but not previously defined.
yeah. So yeah, as you said, it's undeclared. At least not yet. So there's an order of operation, right? We go from top to bottom. We
Mm.
see y before we define it, so that's a problem. Again, rules of algebra. This is what you might find in middle school mathematics. Okay, so far so good. All right, we're going to move on to another idea in algebra, which is functions. So in algebra, we can say f of x is x plus 1, for example. And we're going to do that here, but it's going to look a little bit funny. And so you got to humor me for a moment. I'd like you to delete everything. And I'd like you to
Yeah.
write fun space f opening parentheses x closing parentheses colon
Mm.
new line x plus 1 new line end. All right, notice how the whole thing got highlighted there?
Yeah.
It's because we have just defined a function. Let's run and let's see what happens. Okay, nothing happened, right?
Nothing.
Because we defined the function, but we didn't use it. Or in mathematical speak, we didn't apply the function. Let's create a new line in our program and let's apply the function. Let's write f, opening parentheses, and write any number you want. 5, okay, perfect. Let's closing parentheses, and let's run the program. Get back
6.
6. Nice. And what do we get 6?
Because the function for x plus 1, when I define the value of x as 5, so 5 plus 1 is 6.
Okay, there's variable substitution at play again, right? Whenever it sees x, it sees 5. At least for that function in particular. Okay, great, great. Okay, so notice how there are two windows. The window on the left is what we've been writing in. The window on the right is what have been giving us answers, right?
Mm.
I'd like us to stay on the window on the right. I would like you to write f, opening parentheses, and any number. 7, great. Let's closing parentheses, and let's run it. Oh, don't run, sorry, hit enter, hit enter. Okay, yeah, perfect. You see what's happening?
8.
Let's try it again. Let's write f, opening parentheses, and another number. Okay, let's closing parentheses and hit enter. So it's almost like a one-line program, right?
Yeah.
Yeah. Like we get an answer immediately. Notice how we didn't press run at all. And
Yeah.
notice how it knows what f is. It knows f from the definitions on the left.
Yeah.
So here's what's happening. The window on the left is called the definitions window. This is where we define our program and all the definitions. So like function f is defined here. The window on the right is a thing called the REPL. REPL is REPL. It stands for read, R for read. It reads what you write. E for evaluate. It computes the answer for what you write. So like f of 7, it computes the answer, it gets 8. P for print, it prints out the answer. L for loop, it keeps repeating. So reads what you write, evaluates it, prints it, and lets you do it again as many times as you want. So this is good for very fast feedback. You can get answers very quickly. Not all programming languages have this. Um, this language is designed for beginners, and it's important for beginners to get feedback very fast, and so this language has it. Okay? All right. So just to summarize what we've covered so far, we've covered basically algebra. We have covered the laws of arithmetic, and we can apply the rules of algebra, namely variables and functions. So far, so good?
Yeah, everything. Can you please tell me what a REPL is? A REPL stands for
Oh,
read, evaluate, print, and loop.
E is evaluate. So,
So read, evaluate, print, loop.
exactly. Why is it called evaluate? So, numbers, right? We call them values. Values are answers that cannot be simplified any further. Like 5 is a value, 8 is a value, 11 is a value, 10 is a value. Um, we call anything that you write in this language that the language understands is called an expression. It's like you're expressing yourself to the computer. So 11 is an expression. F of 10 is an expression. Whenever you write an expression, the language will evaluate it. It turns it into a value. So f of 10 becomes 11. So we say the expression f of 10 evaluates to 11. It evaluates to a value 11. You don't really have to know this, but it's good to know. Right? And that's why there's the word value inside evaluate. It's like to make a value. Okay. Um, all right, so okay, just a heads up, I need to send you a new Zoom link because I'm on a Zoom free tier, which only lasts for 40 minutes. Can you check your email? I'm going to send you a new Zoom link there, okay?
Okay.
Okay, I'll see you in a minute. Okay, could you share your screen again? Okay, so far we covered the laws of arithmetic and algebra. We've been working with numbers. It's sort of like we're using a pretty advanced calculator, but we're going to go a bit more than this now. But first, I'll like you to go to the left window, and I'd like you to delete everything and write the number 5. If you could write the number 5 and then just run it. Great. So nothing special. We write 5, we get by 5. Uh, Now, let me ask you, what does 5 mean?
Value, a number.
It's a oh, very okay, very good. It's a value and a number. Okay, now let me change the question. What if I say 5 degrees Celsius? What does that mean?
It tells me how hot or how cool it is. Depends on the context.
Very good. What if I say 5 kilograms?
Mass of something.
Oh, okay, interesting. Okay, I like how you said mass. Okay, very good. So how heavy something, how light something is. So, but even though they're
Uh-huh.
all 5, depending if I say 5 degrees Celsius or 5 kilogram, the 5 means something a little bit different, right?
Right.
So there are two worlds. There is the world of information. This is ideas, facts about the real world. And there's the world of data. This is what a computer understands. 5 degrees Celsius is information, but 5, the number 5 you see in front of you inside your program, that's data. That's what a computer sees. The computer doesn't know if it's kilograms or temperature. It only sees five, right?
Mm-hmm.
Okay. Now, this sounds like philosophy, but it's a very practical idea, and it's going to be the foundations of everything we'll do in these sessions. Our job as a programmer is to facilitate the interaction between these two worlds. Our job is to convert information into data and data back into information. We say that we encode information as data. So like 5 degrees Celsius and we write 5, we say we are encoding 5 degrees Celsius as 5. Another word you might hear is representing. We represent we're representing 5 degrees Celsius as a number 5 in the computer. And then we can read 5 back out and we see it's like, oh, it's 5 degrees Celsius. I'll give you an example. Let's say when you sign up for this office hours, you had to write your name down. So your name is information. Your name is information, right? But when you write your name down in the spread in the Google Forms and submit the form, your name becomes data. It becomes an entry in my database. And so when this meeting was coming, I was like, oh, what's this person's name? I can search up your name and see, oh, that's your name. I read from my database and I know your name. So the data becomes back into information, right?
Okay.
So yeah, there's an interaction between data and information, and our job as a programmer is to facilitate the interactions between them. Okay, so
Mm.
I'm going to reframe everything we have done so far. Right now, all we have done is we have encoded information as numbers, and we have been operating on numbers. Can we encode all information as numbers?
All information as numbers. Is it possible?
I don't know, is it? Is it possible?
No, I don't think. All information as numbers?
Let me ask you this. Have you ever heard the saying that a computer is just a bunch of zeros and ones?
Yeah,
And zeros and ones are just numbers, right?
yeah,
So everything can be encoded as numbers into zeros and ones.
yes,
So everything can be encoded as numbers, right?
yeah.
But do we want to encode everything as numbers?
No, it won't be possible. Like, it's cold, but how cold it is? I feel cold, but how do I express it in numbers?
Exactly. Exactly. Okay. Very good. We can encode everything as numbers, but do we want to? No, we probably don't want to. For example, I'll give you an example. You know how they say that the universe is just a bunch of particles?
Yeah,
But there's a table in front of me. I don't see a bunch of particles. I see a table. But in the eyes of the universe, it see a bunch of particles, right?
yes,
Because it's useful to me to see it as a table, an object, rather than particles. Even though it does not a table does not make sense to the universe. It's just these particles interacting in some way, right? Okay.
yeah,
So we can come to the conclusion that not everything should be represented as numbers. And so what this means is that there must be different representations of information. And I'll show you a new one. Can we delete the five? I would like you to write double quotes. Hello, comma space, world. Closing double quotes. I'd like you to run it. Hello, world.
well,
Notice how we didn't get back a number. We got back something different. We got back a string. It's called a string because I think it's a string of characters. I don't really know, but that's a string. It's like text. Now, this words "hello world," it's a bit of a tradition. In the I think 1970s, there's a programming book, Intro to C programming language, and it used this example, "hello world." And ever since that day, every programming book, tutorial, and video course in the world uses this example, "hello world." Anyway, so this is a new representation, a new data type. So we saw numbers and now we see strings. A number is a data type. A string is a data type. A data type is a classification of data, right? Now, let's see what we can do with strings. So when we saw numbers just now, we saw that we can perform arithmetic on numbers. Can we perform arithmetic on strings? Can we add this string to another string? I would like you to add this string to another string. So you can come with any string you want. Hello world. Okay, very good. Let's run it. Hello world world. See what's happening?
Yeah.
The strings are joined together. The same way we can add numbers, we can add strings. Could we change the plus sign to a minus sign? All right, great. Let's run it. Oh, what's happening?
Yes, right. The operator expects to be given two numbers.
Minus only works on numbers, not strings, right?
Mm-hmm.
So the operations for numbers and strings are fundamentally different. Okay. All right, I would like to try something different. I would like you to delete everything, and I'd like you to write double quote 5, and then closing double quotes, and I'd like you to run it. Okay, you got the same thing back. No surprises here. 5 is a string, just like hello world, it gives us back a string. No surprises. Okay, I want you to, on a new line, I would like you to write the number 5. No quotes. Just number 5. I'd like you to run it. Okay, I'm going to ask you a question, a somewhat philosophical question, and then I need to get water. All right. Now that we have strings, and strings are a series of characters, and the number is displayed as a series of characters, why do we need numbers? Why can't we make everything strings? Okay, think about this question. I'm going to get some water. I'll be right back. Okay, I've returned. So yeah, why can't we make everything strings?
It would be really complex.
What do you mean by that?
Uh, Separating numbers with strings would make uh, the classification a bit easier.
Okay, so your argument is convenience, right?
Yeah,
Okay. Oh, that's a good answer. Uh, Another answer is that for- we can subtract numbers, but we can't subtract strings, right?
yeah,
And when we add two numbers, that's very different from adding two strings. We can do different things with different data types. So
yeah,
while the same piece of information can be represented with multiple data types, there are strengths and weaknesses to each data type. And remember how I said our job as a programmer is to facilitate the interaction between information and data? Well, part of our job, and in fact, I would say a very important part of our job is knowing what representations we should use for a piece of information, right? Like temperature 5 degrees Celsius, we should probably use a number. My name, Marvin, I should probably use a string, right?
yeah,
Okay. So we have covered two data types so far, numbers and strings, and we showed that we can do arithmetic on both of them, even though arithmetic looks very different for each. I'm going to introduce a third data type. Um, so this is a very important data type in life. Life can be said to be a series of decisions, and a decision is fundamentally yes or no. For example, your decision to come to this office hours, you must have said yes, right?
yeah,
Decisions are very important idea of life, but also in computers. In fact, our computers, they're made by decisions. Our computer is making decisions all the time. So decisions are so important that most programming languages have a data type to represent decisions. And this data type is called booleans, named after a person called George Boole. Boole is a mathematician that studied these things as mathematical objects. Anyway, in computer science, these booleans are true and false. So let's delete everything. Let's delete the fives. And let's write true, True. And let's run. Okay, we get back true.
true.
Notice how the true is red in color. It's a special keyword. It's a
Yeah.
special citizen in this programming language. Now let's replace true with false. 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 And let's run it. Okay, we get back false. So that's pretty good. So true and false. Now I'd like you to write something. I'd like you to write false or true. That's or false or true. Notice the or is bolded. It's a special thing. So let's run it. False or true is
True.
true. Notice how we have two booleans, false, true, and then we reduced it to one. Okay. Let's replace or with and, A-N-D. False and true. We get back false.
False.
Okay, so we call or and Boolean operators. These are like plus and minus. So the same way we can add numbers, we can add strings, we can also add booleans. We can operate on booleans, right? Okay. I'm going to share my screen for a second and I'm gonna start wrapping up. Give me one sec. One sec. Okay, I'm gonna share my screen. Do you see my screen?
No.
Oh, trying to zoom in on this, but it's not working out. Okay, that's close enough. Okay, you see this here? You see a bunch of tables? These are truth tables. And another way of understanding Booleans is that they encode truth, whether or not something is true. A zero is false and one is true. Um, Remember how I said that computers are a bunch of zeros and ones?
Mm-hmm.
These are the zeros and ones. These are it. And these are Boolean operators. They can tell us how whether something is true and false and how they combine. For example, when I say like false and true is false, false and true, zero and one is
Yeah.
zero. False or
Mm-hmm.
true is true, zero and one is one for or. So these are the rules of Boolean operators. As a programmer, you only need to know not, and or. Um, Unless you're into electrical engineering or cybersecurity, it's good to know all of them. Now, the reason why, so like, if I ask you, like, if you have an apple and banana, sorry, if you have an apple but you don't have a banana, and I ask, do you have an apple and a banana? You'll say no. I only have one of them. If you have an apple but you don't have a banana, and I say, do you have an apple or banana? You say, yes, I have an apple. I have one of them. So that's the intuition behind that. These here are logic gates. These are the fundamental building blocks of our computers. These are like physical objects. There are thousands, millions, billions of these that create our computers. And our computers are a bunch of zeros and ones, and these things here, they compute on the zeros and ones. They process the zeros and ones into more zeros and ones. And this is how computation is possible. This is why we have computers right now. Okay. Um, I think it's time to start wrapping up. So just to summarize what we have done today, we have covered three data types: numbers, strings, and booleans. These three, they're like cash. If you're lost in a city and you have cash, you can probably get what you need. If you have information you want to represent, you're going to probably use one or more of these three: numbers, strings, and booleans. All right. So I always like to end my sessions by asking the student, what is one thing you learned today that stuck with you?
That's it. Uh, Data types and their classification.
Very cool. Okay, so I usually don't give homework unless you want home. If you want homework, I'll give you a bunch of homework, man. Uh, so yeah, the pace of this call is completely up to you. Do you have any questions?
No, until now, no. I'm still. I have noted everything that we have discussed so far, and yes, I would love you to. I would really love you to give me homework.
Wow. Okay. Um, I'll think about what to give you and I'll email it to you. I need to have
Yeah,
a think.
uh,
Okay.
that would be great.
Okay. I think I'm going to call it here. All right. Thank you so much, Mohammed, for coming. I'm very happy to be able to help you on your journey to programming, and I hope to see you again.
It was really my pleasure, my honor. Thank you.
Right. Bye bye.